So in this one, we're going to combine our previous videos and add in mole ratios. So the first thing that we're going to do to start off with is we're going to write an equation. We're going to say hydrogen plus oxygen yields water. Now we know from our previous units that the first thing that you need to do is to balance the equation. So now I have 4 hydrogens on both sides, and I have 2 oxygens on both sides. When we talked about this before, that meant that, the H2s were combined. And so what this meant is that I had 2 H2s. Over here, I had 2 oxygens. So that meant that over here, it allowed me to produce 2 waters. That's how we talked about it before, as individual particles. Well, now we're going to talk about it on a much larger scale, because it's unrealistic that I'm going to take 2 H2 particles, combine it with 1 O2 particle to get 2 molecules of water. That's a bit unrealistic. So instead of those numbers representing individual atoms and molecules, just like when we did our molar mass, these are now going to represent the amounts of moles of each substance we need. And so this tells me that for every 2 moles of hydrogen, I require 1 mole of oxygen, which will allow me to produce 2 moles of water. And so now I can use these to convert between things. For example, let's go ahead and write underneath these the molar mass of each of these items. And if you don't remember how we got these, then you can go back to a previous video and watch how to obtain molar mass. Should be an 8 for 18. And so now I know their molar mass, or how much there is per mole. And so now, remember we said the whole reason we use moles is because it allows us to compare. It allows us to get that proper ratio. And in earlier units we determined that getting the proper ratio allows us to have the most efficient reaction. So I can't just go dumping stuff in. If I dump in 20 grams of hydrogen and 20 grams of oxygen, I'm going to have that extra oxygen taking up the space that a viable reaction could occur, or the extra hydrogen taking up the space that a viable reaction could occur. And so, let's say that I'm in the lab and I know that I have 10 grams of hydrogen. And I want to make the most water possible from this reaction. So I have 10 grams of hydrogen. I need to determine how much oxygen needed for it to completely react. So for all 10 grams of hydrogen to be used. So once again, I underline what I'm starting with, and I'm going to circle what it is I want to end with. So my hydrogen goes over 1, because that's my given. And we are going to use our symbols here. This is very important. I said in our last video how important it was that you put your molecular formula. And now we're going to see why. So first things first, remember I said, and this is very, 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 very important, I cannot emphasize it enough. If given grams, you must convert to moles. And remember, this is because we said you cannot compare grams of two different substances. You can only compare moles. So, since I'm given grams of hydrogen, I need to first convert that to moles of hydrogen. So I know I need my grams of hydrogen to cancel out, and I need it to convert to moles of hydrogen. I do that using my molar mass. So I notice that up here, it says that for every 2 grams of hydrogen, that is 1 mole of hydrogen. Well, I don't want to stop there. If you want to break these down into individual little problems, feel free to break it down there and then carry down the answer that you get here as your answer as you're given for the next one. So in other words, if you took 10 divided by 2, then you would get 5 moles of H2. So if you wanted to, you could start with 5 moles of H2, as our new given. So it would go over 1. I'm going to continue on with this problem in a single line. So now I have moles of hydrogen. I need to figure out how many grams of oxygen it is. But like I said, you can only compare moles. You can't go from moles of hydrogen to grams of oxygen. So I'm going to use my mole ratio. My mole ratio is what I get by using my balanced equation. So I know that I need it to go from moles of hydrogen, so those need to be on bottom so I can cancel out, and I need to convert it to moles of oxygen. And so by using my formula, I can see that 2 moles of hydrogen are required for every 1 mole of oxygen. So that's exactly what I'm going to write. Same thing now. I'm going to cross off my moles of hydrogen. I don't want to end with moles of oxygen. I want to end with grams of oxygen. So once again, now that I'm at oxygen, I can use my molar mass to compare moles of oxygen to grams of oxygen. And so I have 1 mole of oxygen is 16 grams of oxygen. This is why I want you to write your formulas with the moles and grams, is because it's going to help us keep track of which substance we're talking about. Otherwise, it's really easy to get confused with that. Like I said, if you wanted to, and if you continued this as your own different problem here, then we would have had 1 mole of O2 over 2 moles of H2, and that would have given us 2.5 moles of O2. So that's perfectly fine. You can use it as a stopping point, and then if you went and decided to make that your new given. So all I'm doing in these other ones is I'm just breaking apart the formula. It's however you want to do it. It's whatever works for you. So then in this case, then I would go from the moles to the grams the same way I did before. And I'm going to get the same answer in both cases. So let's type this into our calculator. And we get 40. Don't forget your unit. And so, in order for 10 grams of hydrogen to completely react, we need 40 grams of oxygen. This is why I said we can't compare grams. I can't say that, well, I have 10 grams of hydrogen and 10 grams of oxygen, and so it's equal, it will work. That's not how it works, okay? So by doing this, this is how we can compare using our various different ratios. I will post some practice problems for you to work out. If you require another video of me working out a trickier solution, let me know and I will gladly do that. Otherwise, this is what you are expected to be able to do. Also keep in mind that I could ask how many particles something is. I didn't do that in this example. Let me go ahead and do an example of that real quick. So let me say that I have 10 grams of water, and I want to know how many particles of hydrogen are needed or are produced. So in this case, we're going to do the reverse. We're going to go from water, and we're going to do a decomposition reaction. I still need to balance it so that I have my ratios. And so now I'm going to start with my 10 grams of water. As I said, I cannot compare grams. I have to compare to moles. So if given grams, always convert to moles first. So my grams of H2O, 1 mole of H2O, we said was going to be 18 grams. That was from our molar mass. Well, now that I have moles of H2, I can compare, or moles of H2O, I can compare it to moles of H2. So I'm going to go ahead and put mole of H2O and mole of H2. In this case, it's going to be 2 for each of them. Now, most of you can probably follow through to that point, but the tricky part is where it says number of particles. How many particles? Well, if you remember, 1 mole is 6.023 times 10 to the 23rd particles. So I can convert from moles. So 1 mole of H2 to 6.023 times 10 to the 23rd particles of H2. And then that is how I get my answer. Once again, we're going to plug it into our calculator. And if I punched it in correctly, I get 3.35 times 10 to the 23rd particles of hydrogen. So just to summarize, when going from grams to moles or moles to grams, you are going to use your molar mass. When you are going from moles of substance X to moles of substance Y, or moles of substance Y to moles of substance X, here you're going to use your moles from the balanced equation. If you are asked to obtain particles, then you're going to have to go from moles to particles, or if you go from particles to moles, you will have to use Avogadro's number. Which is our 6.023 times 10 to the 23rd. Hopefully this helps. I will post some extra practice on Schoology for you to do. If you need a video